Alright, so today we're going to look at solving exponential functions and solving log equations. So remember log equations. So let's just say I have log base b of some number is equal to something. Okay, remember we could rewrite this as b raised to the x is equal to a. So remember log equations can be rewritten as exponentials. Alright, so the first thing, there's lots of different ways to solve log and exponential functions. So we're going to go through those. Alright, so exponential functions when the bases are the same. Okay, so when the bases are the same, we will set the exponents equal to each other. Alright, so let's do this one. So 81 can be rewritten as 9 squared, right? So this will be 9 squared. So this will be 9 to the first power, and this will be 9 to 2x. So the bases are the same. So now I'm just going to set the exponents equal to each other. And then I'm going to solve. So I divide by 2. So x here would be equal to a 1/2. Good deal? Alright, let's look at this one. So I've got 5 to the x is equal to 1 over 25. So can I take that 1 over 25 and put it into base 5? So what is that? So this would be 5 to the negative third power. The exponents are, so the bases are the same, so I'm going to set my exponents equal to each other and I'm going to solve. Not much solving there. Alright, let's look at this next one. So I've got 7 raised to the 6x minus 2 and 49 raised to the 2x minus 5. So can I get the bases to be the same? Okay, so 49 is the same thing as 7 squared, right? And then you're going to raise that to 2x minus a 5. So I'm going to set the exponents now equal to each other. So that'll be 6x minus a 2 is equal to 2 times, because remember you multiply those exponents like that. So this will be 6x minus a 2 is equal to 2 times 2, which is a 4x, 2 times a negative 5, which is a negative 10. Subtract your 4, so you'll have a 2x. Add your 10, so you'll have a negative 8. So x will be equal to a negative 4. Okay, so that's when the bases can be the same. Okay, all right, let's look here. So what about these types where they are not the same? So I have 10 raised to the x is equal to 7. So this is where we're going to be using a calculator. Okay, so we'll have to use a calculator here. So when the bases are not the same, you can rewrite as a log or natural log, right? So log or natural log. Oops, sorry. So far over there. All right, so this could be rewritten as log base 10 of 7 is going to be equal to x. Okay, so now I'm going to use the change of base formula, but you know in your calculator you can just plug this in because it is log. There it is, can't find it. So log of 7 is going to be, so here is going to be equal to 0.845. Okay. All right, let's look at this one. So I've got e to the x is equal to 50. So remember, e is the same thing So remember, if you have an e, say like this, remember, instead of saying log, you'll say natural log of y like this. So this will be natural log of 50 is equal to an x. So then natural log of 50. So x here is going to be equal to 3.912. You can trick yourself, right? So e raised to that number is going to give you a 50. All right, let's look at this one. So this one, to rewrite it as an exponential, I do need to get this by itself. Okay, so I'm going to get this term by itself. So I'm going to subtract. So this is going to be 3e to the x. 26 minus 5 is a 21. Divide both sides by 3. So I'm going to have e to the x is equal to a 7. So now I rewrite, right? So rewrite it. So it'll be ln of 7 is equal to an x. So ln of 7 is going to be 1.9459. So roughly that's going to be 1.946. Okay. All right. Okay, so what about this one? So I want to think about this one for a second. So this is e to the x plus 1 is equal to 7, or I'm sorry, 3. 3 to the x plus 1 is equal to 7. So the bases are not the same, so I can rewrite it as a log equation. But let's look at this one right here. These two, okay, so these two are not the same base, but they are raised to another exponent. So I can't write these as, rewrite these as a log. So what we will do, and I'm going to go ahead and do it to this one so that we can see what's happening. So I want to take the log or natural log of both sides. Okay, so I want to take the log or natural log of both sides. Okay, so I'm going to just take the natural log. So I'm going to take natural log of both sides here. And we need to remember our rules here. So remember, if you've got a natural log or a log in the front, and I want to expand this, what can I do with that exponent? So that exponent can go to the front. So this will be x plus 1 times natural log of 3. Okay. I can then divide both sides by natural log of 3. So then you'll have x plus 1 is equal to natural log of 7 over natural log of 3. Solve for x. So x is going to be the natural log of 7 over the natural log of 3 minus a 1. So natural log of 7, make sure you close that parentheses, divided by natural log of 3, close that parentheses, minus a 1. So it's going to be a 0.771. Okay, let's look at this one. Okay, so I want us to do the same thing here. So here, we're going to take the natural log, and those can come down. So I'm going to have x plus 1 times natural log 3, 2x plus 1 times natural log of 7. Okay, so let's simplify a little bit. So I'm just going to go ahead and divide by that natural log of 3, so I'll have 2x plus 1 natural log of 7 divided by natural log of 3. So I'll have x plus 1 is equal to 2 times the natural log of 7 divided by the natural log of 3x plus natural log of 7 divided by natural log of 3. And then you'll have, combine your like terms, so x, move the x to the other side. Like this, and then you'll have natural log of 7 divided by natural log of 3 minus a 1. So very similar to up here, but we've got to deal with this exponent here. So here I'm going to just factor out the x, so I'll have 1 minus 2 natural log of 7 divided by natural log of 3. And I'm just doing this because I don't want to put all this in my calculator and carry decimals across the whole entire thing. I divide both sides by that big, so this will be natural log of 7 divided by natural log of 3 minus 1, all over 1 minus 2 natural log of 7 divided by natural log of 3. And then I can put all that in my calculator. So, natural log of 7 divided by natural log of 3, close that parentheses, minus a 1. Okay. So I'm going to have 0.771243749 in the numerator. Just have something big up there. 1 minus 2 natural log of 7 divided by natural log of 3. So it'll be a negative 2.542487. So 0.7712433749 divided by is going to be negative 0.3033. Okay, so solving exponentials if the exponentials are the same. So if the bases are the same, okay, we get the bases to be alike, okay, and set the exponents equal to each other, okay. If the bases are not, we can rewrite them as an exponential. We can rewrite the exponentials as logs, okay, and solve from there. If I've got two bases, different exponents, then this is when we can take the natural both sides. Okay, so that is solving exponentials. So the next one is going to be solving log equations.